Hello and welcome back to math class. Today, putting quadratic functions into vertex form. There are different ways to express a quadratic relation. There's this form, which is called standard form. It's when all the terms are separated. A number of x squareds plus a number of x's plus a constant term. ax squared plus bx plus c. And it yields a piece of information. It tells us about the y-intercept. This number on the end is the y-intercept. It's 0c. And so in this particular case, the y-intercept is 0 minus 30. Now, if we were to take this very quadratic and factor it, we'd have this form. It's a different form. It's called factored form because it's been factored. And in general, we could call it a number times x minus r times x minus s, where the x-intercepts are now displayed in the factored form. The x-intercepts are this r and this s number that are in brackets with the x. X-intercepts are otherwise known as zeros. So the zeros are r and s. And so for this particular parabola, which is the same as this one, by the way, the zeros are -5 and +3. Notice how we change these signs, because we're subtracting the zeros from x. And x subtract -5 is x plus 5. Finally, we have this form, which is called vertex form. It's a square, a multiple of a square plus or minus a number. You can recognize it by the squared binomial. Vertex form. In general, a multiple of a square, so a times x minus h squared plus k, where the vertex in general here is hk. And so for this particular parabola, which was the same as both of these, by the way, the vertex is at -1, -32. Now, moving between the forms is generally pretty easy. To get from standard to factored, you have to factor. To get from factored back to standard, you have to expand and simplify. To get from vertex form to, say, standard form, you have to expand and simplify. The question is, how do you get from standard form to vertex form? That's the topic of today's lesson here in math class. Express a parabola in vertex form. Well, here's a parabola -2x squared plus 20x minus 35. So, for solution, the solution is to complete the square. So we're going to take our parabola, which was given, copy it, and we have to complete the square. And there's a number of steps, which I will outline here. First, factor out the coefficient of x squared. Look at the x squared term. This number, which we know is called a coefficient, it can be factored out. Even if it doesn't come out evenly, it can still be factored out. But don't take it out of all three terms. Just take it out of the first two, like this. This number on the end, the constant term, stays out of the brackets. And when you write a line, let's check a line. Multiplying this out mentally, we have -2x squared. That's good. And -2 times -10 is +20x. And that's good. Remember, this number, the constant term, stays out of the brackets. Next, I haven't done a thing. All I've done is made some room in the round brackets. I made some room that we're going to fill in. The question is, with what? I mean, I copied the -2, I copied the -35, I copied the contents of the brackets. I just made some room. And inside the room, this is what you put. Focus on that coefficient, the coefficient on x. And you have to do 4 things to that coefficient. These are the 4 things. You have to divide it by 2, square it, add it, and subtract it. So divide it by 2. When it's even, that's easy to do. So 10 divided by 2 is 5. And then square it, and that's easy also. 5 squared is 25. And then you have to add it and subtract it. And you have to remember those 4 steps. Divide it by 2, square it, add it, subtract it. So it'll be 25 added and subtracted in that order in the room that you made in the brackets. That done, we have to do the next step. And that is remove the 4th term. Let's count the terms inside this bracket. 1, 2, 3, 4 terms. We have to remove the 4th one. But this minus 25, which is the 4th term, doesn't just step outside of those brackets because it's inside a set of brackets that's being multiplied by 2. We have to observe this. That negative 2 is multiplied into the bracket, so when the minus 25 does step out, it becomes plus 50, like that. And now the final step is to repackage the square. What we've done here is we've engineered a perfect square trinomial. We built this on purpose by dividing something by 2, by squaring it, by adding it and subtracting it. We have always built a perfect square here. And this can be repackaged. So let's write a line and check a line. We're going to repackage this square. Now, I've repackaged it as the square of a binomial. Let's check our work. To square a binomial, it's the first term squared, x squared, that's good. And then double the product. Double minus 5x is minus 10x, that's good. And then on the end, it's always plus, and it's this number squared. So plus 25, that also is good. So we've repackaged these 3 terms. And we collected like terms here with the constants. Plus 50 minus 35 is 15. And what we have here is vertex form for the original question. We can state the vertex now. It is 5, 15. Notice how we change the sign, leave the sign when we state the vertex, 5, 15. Now that we've completed the square and found the vertex, let's analyze our result. We took this parabola, this quadratic relation, we rearranged it into vertex form. Let's now interpret the results. Okay, it's a quadratic, yes, because it's a square. This x is squared. We have the square here, so it's a quadratic which opens. Now we have to choose up or down. I see a minus sign on the square, so this one opens down. A quadratic that opens down has is it a maximum or minimum? If it opens down, it has a high point called a maximum. This maximum value is y at the vertex. Well, we know the vertex is 5, 15, so the maximum value is the 15. And this maximum value occurs when the x value is x at the vertex. And we know this is where we change the sign, so when the x value is 5. For exercise purposes, let's do this again. Put into vertex form. Negative 3x squared plus 15x plus 4. Solution, complete the square. Step 1, factor out the coefficient on x squared. Done. Write a line, check a line. Let's see if it's right. If you multiplied it in, we'd have minus 3x squared. And if you multiplied it in over here, we'd have plus 15x. Looks good. Now we have to take the 5, cut it in half, square it, add it, and subtract it. Those are the 4 steps. Before we do that, let's note that 5 over 2 squared is 25 over 4. So when we cut it in half, we'll get 5 over 2, and when we square that, we'll get 25 over 4. So we'll take that and add it and subtract it. Now we have to remove this 4th term. So it'll be minus times a minus is a positive, and 3 times 25 is 75 over 4. And now repackaging the square, it's always pretty easy. We'll take this x squared without the square, so it'll be x, and with the square root of this third term. The square root of this is 5 over 2. The square root of the top over the square root of the bottom, with this sign, which is minus. And so here we have this perfect square repackaged. We can check our work. First term squared, looks good. Double the product, so the 2 will cancel, and we have minus 5x, that's good. And then over here on the end, the positive of this square, which is 25 over 4. That looks good. And 75 over 4 plus 4, well, hopefully we're learning to add fractions. And 4 over 1 is 16 over 4, so 75 plus 16 is 91 over 4. With a vertex at change the sign, leave the sign, so 5 over 2, comma, 91 over 4. Analyzing. Okay, it's a parabola. Does it open up or down? It opens down again because of the negative. It would therefore have a maximum value because it's a parabola that opens down. And this maximum value is the y value on the end, the y value at the vertex, 91 over 4. And this maximum value occurs when the x value is x at the vertex, positive 5 over 2. One last one just for practice, and this one has a fraction in it. Solution, complete the square. Well, we've just done this twice, so we can do a couple of steps at once. Common factor out the 1/2. So there it is. That means 6 divided by 1/2, which is actually, well, 6 divided by 1/2 is the same as 6 times 2, which is 12. That's why I see the number 12 here. A lot of people think that when you factor out the 1/2, the 6 becomes a 3. No, it becomes 6 divided by 1/2, and that's 12. And you can check your work by multiplying 1/2 in. You got 1/2 x squared, and 1/2 times minus 12 is minus 6. And then take the 12, cut it in half, or divide it by 2, square it. So 6 squared is 36, add it and subtract it. Next, the fourth term can step out, but not without being multiplied by the 1/2. So 1/2 of 36 is 18, so it steps out, it becomes minus 18. Now let's repackage the square. And we'll take this x squared without the square. We'll take the sign that we see here, and we'll take the square root of this number on the end, which is 6. We'll check our work by saying I've written a line. Let's check it. So squaring this binomial, the first term squared is x squared. Double the product is minus 12x. And then on the end, the positive of 6 squared is 36. And minus 18 plus 1 is minus 17. And we found the vertex once again.